Hi, my name is Tislim Dosumu, and today I'll be presenting about a project that I worked on called Take 5. So Take 5 is my attempt to create the perfect personal productivity app. It combines the basic idea of a to-do list, but solves the problem that people have where, given all of the tasks that you have to complete, you're not sure which ones to take on. Using Take 5, it automatically chooses a set for you to work on in a given time frame, which makes it easier for the person to focus on just getting things done. Take 5 is composed of a few different components. It follows a model view model architecture. It uses Room for persistence. It takes advantage of async tasks using coroutines and threads. It also makes use of observables with RxJava and RxKotlin. And then the specific Android system features that it uses are the countdown timer, system time, and of course, threading. Model view model is essentially the future of data-driven interfaces. It's broken up into three parts: the view model, and model, each with their own separate concerns and communication with only one other layer. The view is the user-most facing component of this architecture. It interacts with the view model by calling view model functions and then uses observables to watch the state in the view model and update the interface based on the data that's stored in that state. The view model sits between the view and the model, hence the name, and provides an observable state for the view and exposes specific functionality for the entire system. And then the model, of course, just controls the data. It exposes the API to make use of the data and also handles storing it and accessing it. Observables are essentially a message pipeline interface. It allows you to compose streams of data between different components and allows you to set up functions along the streams that can modify data and pipeline it to where they need to go. It's very similar to operating system messaging abstractions. And this allows for real-time updates to different components that are watching data. And of course, with this kind of application, we don't want to lose the tasks whenever the application is close, so we use persistence. Android uses SQLite to provide database functionality, but SQLite by itself is complicated to write all of the code for, and so we can make use of what other people have written, which is where Room comes in. It essentially provides an expressive interface to integrate database functionality with very little code. The core system APIs that were used. The first thing that was used are async tasks and coroutines. With operating systems, of course, there are multiple ways to implement job processing, but the interface can be fairly clunky. So having to use pthreads, that sort of thing, it requires a really good understanding and a lot of boilerplate code. And that's where coroutines come in. Coroutines essentially combine the idea of setting up threads and then setting up how threads communicate with each other in very simple code. You essentially offload chunks of work that would block rendering on the UI thread into other threads, so background work, and then only notify the UI thread when it needs to make changes to itself based on the data that was produced by the background thread. And so with coroutines, you essentially have three different contexts that threads execute in: the IO context for input and output operations that require accessing data on disk, that sort of thing, UI threads for making updates to the user interface, and in my particular architecture, there's also the view model context, which essentially allows me to control the execution of different threads based on whether the view model is currently active or not. So for instance, if a view model is currently executing a database query, but the view that it's attached to closes because the user switches to a different fragment or different view, then I would want whatever process was running for the view model to be killed. And then the specific Android system APIs that were used for this project are system time in order to, of course, get the time for different contexts, a countdown timer in order to periodically execute different functions over a period of time, and then, of course, threads, which I've talked about already. And so now we'll get into the demo. The application starts off in a home view that lists all of the tasks that you've created so far and gives you a couple options for navigation, namely schedule and take 5, and of course back to tasks. And you're provided two buttons: take 5 to start a new take 5 session, and of course, create tasks to actually add new tasks. So we'll go ahead and take a look at creating a task. It allows you to add a summary, some description to the task, list how long it'll take to complete the task, when it's due, which will actually open up a date dialog, and a priority that you can set. So we'll go ahead and say upload YouTube video of presentation. So go ahead and add this task. Now it shows up in our task list. And you know what? I have 30 minutes to kill, and I'm not really sure what to do. The three tasks are just too much to pick from. So you know what? Application, give me some things to work on. So we take 5, we start a new take 5 session. We have 30 minutes. It shows when that session was started, and then the randomly picked task to complete, which in this case are present take 5 app for project 2, which I will actually be able to mark off now. Upload YouTube video presentation, which I will do later, and then complete the project report for the class. And that's basically the functionality. I actually find this, even in a bare bones state, to be pretty neat, and I'm definitely going to keep working on it. Thank you for watching.